Hi, my name is John. I'm going to be going over Chapter 1 review test for Charles P. McKeague. One of the teachers at Venture High School created a sample Chapter 1 review, so I'm going to be going over the even ones with you guys. Make sure you understand all of these before you take the test, and good luck on your test. The first one is you have a question 7, y, 3, 5, and the distance between those 2 points is 5. You want to find the values of y. So what you're going to be doing here is that you're going to be using the distance formula. The distance is equals square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, of course. And the distance, we know that this distance is 5. Excuse me. 5 is equal to square root of x2. x2 is 3 minus 7 squared plus y2, 5 minus y squared. Hopefully I wrote it down correctly. 7 comma y and 3 up. Excuse me, I miswrote it. This should have been 3 comma 3. Looked a little bit off. So y2 minus y1, 3 minus 3. That should have been 3 right there, guys. Sorry about that. Anyways, so let's get started. What I'm going to do is, to get rid of the square root, the first thing you have to do is take the square both sides. So that gets rid of the square root here. If you take the square of the left side, you have to take the square of the right side. And that's what we're going to be doing. So on the left side, you get 25 is equal to 3 minus 7 is negative 4. Quantity squared is 16 plus 3 minus y quantity squared. And then subtract 16. Or at this stage, what a lot of people do is they just distribute this out. There's an easy way to solve this, and this is the way you're going to have to learn how to do it in Algebra 2. Anyways, so subtract 16 to both sides. That gets rid of that. You get 9 is equal to 3 minus y quantity squared. Again, the inclination for most of my students is to try to take the FOIL this out, basically distribute the squared, and then move the 9 over and solve a quadratic. There's an easy way to do this, guys, and make sure you learn how to do it. Take the square root of the left side, square root of the right side. That cancels itself out. So I'm going to put the right side on the left. So 3 minus y is equal to plus or minus 3. This is a major step that everybody forgets. When you take the square root of both sides, you have to put plus or minus on one of the sides. So y, 3 minus y is equal to negative 3, or 3 minus y is equal to positive 3. Solving for y, you get y is equal to 6, or y is equal to 0. Make sure you can do this out. There's a reason for this, and I'll explain later after we do problem number 2. When we have some space here, I'll work out the reason why that happens. Anyways, for problem number 2, it's a right triangle, so you're going to use the Pythagorean theorem. Oh, another point right here. On problem number 1, I saw a problem very similar to this on the SAT. So if you, of course, most of you will be taking the SAT. Make sure you know how to do this type of problem because it will come out again on the SAT, just like this one as well. Okay? A lot of these geometry questions will come out on the SAT as well. So how do you solve this out? Using the Pythagorean theorem. X squared plus x plus 2 quantity squared is equal to root 10 squared. X squared, you do have to fold this out. X squared plus 4x plus 4 has to equal root 10 squared, which is 10. X squared plus x squared is 2x squared plus 4x. I'm going to subtract 10 to this side. Minus 6 equals 0. Factor out 2. X squared plus 2x minus 3 equals 0. And I'm going to factor this next. I'm going to use the 4th step. That's step 1 right there. Step 2, put in your first factors. Step 3, the minus tells you, this minus right there tells you one of them is going to be a plus, one's going to be a minus. Step 4 says, check your 3. What are the factors of 3? 3 and 1. Which one goes with the 3? 3 and 1, 3 and 1. Ah, there it is right there. 3 and 1. Did that on purpose. Check your oil in your foil. 3x. Outer is minus x. Inner is plus 3x. You get plus 2x. and then minus 3. Always check your oil in your foil, guys. Okay. So solving it out, x is equal to negative 3 or x is equal to 1. Of course, x can only be 1 because you can't have a negative distance right here. Okay, most of you know that. Let's work it out. 1 squared plus x is 1, 3 squared is 10, and so that should be the square root of that. A squared plus b squared equals 10 squared, and it actually works out. Let's go revisit this question one more time. And it says it's going to be 7 comma something, so I'm going to draw this out for you to see how it works. At 7 comma 0, here it is, 3 comma 3 is located right here, and 7 comma 6 is located here. That's 3 comma 3. Notice if you take the distance of here or here, you should get a distance of 5. I'm going to use a different marker for this one. I'll show you the reason. From 3 to 7, the x distance is 4. And that distance from 3 to 7 6 is up 3. This has to be 5. And if you go down 3 as well, this distance has to be 5. It's a 3, 4, 5 triangle. And so you are going to get 2 points here when it gives you some kind of question like this. Make sure you can do this again. There's a problem like that on the chapter test as well, chapter 1 test. Make sure you know how to do those. Okay. The next question. If the cosine of the angle, whatever theta is, happens to be 2 over root 13, and theta happens to be in quadrant 4, find all the rest trigonometric functions. It's a little tedious on this problem because there's lots of things to do, but it shouldn't be too difficult. So I'm going to start using a lighter pen. This value right there, that's your x direction, and that on the denominator, the ratio is your radius direction. So that's the first thing you should do all the time when you're trying to figure these out. Cosine is the adjacent side over the hypotenuse. If you're not familiar with that, draw the triangle. That's theta right there. That's x. That's r. And I'm sorry, that's y, and that's x right there. Okay. So if you're not familiar with it, draw the triangle in the xy coordinate. Make sure it radiates out from the center to the quadrant, and then that's your y direction, and that's your x direction. And the cosine, of course, is adjacent over hypotenuse, or x over r. There it is, okay? Once we figure that out, we have to find out what y is. So x squared plus y squared is equal to r squared. In this instance, it's in quadrant 1, so y is going to be positive. But in quadrant 4, y probably is going to be negative. Well, how do we figure that out? X squared was 2 squared plus y squared is equal to r squared, square root of 13, quantity squared. 4 plus y squared is equal to 13, subtract 4, y squared is equal to 9, y must equal plus or minus 3. Well, which one is it? When you take the square, don't forget, when you take the square root of both sides, you have to put plus or minus. Well, which one is it? Because it's in quadrant 4 right here, the y direction is going to be minus. So that's the correct one that we're going to have to use. And you can kind of tell if it radiates out in the 4th quadrant, the y direction is going to be negative. Okay, so that should solidify it graphically, mathematically, guys. So how do we find the sine of theta? The sine of the angle is equal to y over r, which is equal to negative 3 over root 13. The reciprocal function of the sine is the cosecant of the angle is equal to, flip that around, root 13 over 3 with a negative. We have the cosine. The reciprocal function of the cosine is the secant function. Just flip that around, root 13 over 2. We should also know the tangent of the angle. We know that to be y over x. Can you see that right there? The y opposite over the adjacent. We know the y value is negative 3 over the x, which is 2. And then the cotangent is the reciprocal function, which is x over y. 2 over 3 with a negative in front. Okay, so that wasn't too bad, guys. Let's try to work on the next problem. 1 over cosine theta minus cosine theta, and we want to try to evaluate this expression or simplify this expression, excuse me, guys. So how do we simplify that? First thing we're going to do is we're going to put it over 1. And one of the students came up to me and said, well, what are you going to do here? I'm going to give you a simple example. If I go 4/7 minus 3/5, the common denominator here is 35. So you have to multiply the first term by 5, the numerator and denominator. The second term you have to multiply by 7, top and bottom. Does that make sense? I mean, you have to have 35 in the denominator, so you have to have the common denominator. Well, here the common denominator between these two terms is cosine theta. So what I have to do is I have to multiply by the cosine of theta in the denominator. And if I do it to the denominator, I must multiply by cosine of theta to the numerator. So you have 1 over cosine of theta minus cosine squared of theta over cosine of theta. That's what it becomes. And then we put it all under the common denominator, which is cosine theta, and the numerator you have 1 minus cosine squared theta. If you leave it like this, the teacher will mark it off. We know that the sine squared plus cosine squared is equal to 1. If I move the cosine squared to the right side, this whole thing becomes sine squared of theta. So that becomes sine squared of theta over the cosine of theta. Okay? Some basic information right there. Let's do the next problem. They want you to actually distribute this out. Cosine theta minus 3, parentheses, 2 cosine theta plus 5. We're going to fold this out. Cosine theta times 2 cosine theta is 2 cosine squared of theta. Outer cosine theta times positive 5 is plus 5 times cosine of theta. Inner minus 3 times 2 cosine theta minus 3 times 2 is negative 6 minus 6 cosine of theta. And then minus 3 plus 5 is minus 15. We're just folding these out. You end up with 2 cosine squared of theta. You notice that these are like terms. Minus cosine of theta minus 15. Okay? Pretty easy. It wasn't too bad. Just fold these out. Make sure you get your outer and your inner combined together. Number 6. It says simplify this term and simplify this expression, excuse me, in terms of sines and cosines only. Yep, that's what it says. Now, what does it say? I can't really read it. Right, sine theta, tangent theta, plus cosine theta in terms of cosine of theta only. This is a little bit difficult. So, first of all, we change everything from secant, cosecant, tangent, cotangent into sines and cosines. So we drop this out. Sine of theta times tangent theta is sine of theta over cosine of theta plus cosine of theta. And then let me just make sure in terms of cosine only. We know that. Wait a second, let's do this again. There's several ways we can do this. But I'm going to do it this way. You want it in terms of cosine theta only. Well, what do we know? Sine squared of theta plus cosine